This is the periodic table. These are the rows and these are the columns. The first is the alkaline metals, and the second one is alkaline earth metals. And then this one is transition metals. This one is core metals. And then you can see it's boron, aluminium, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are metal layers. Then these ones are halogens, and these ones are noble gases. And then you can see this is the element. So the atomic number is this one, which is 1, and then the H is the symbol. Then the name is hydrogen, and the atomic mass is the little number at the bottom of the element. And it can conclude with all the elements of the periodic table.
Also, you can know the valence electrons. The maximum amount of valence electron it can be less than 8 or equal to 8. So here, in the first column you have 1A, you have 1 valence electron. In the second column you have 2 valence electrons. In all the B group, you can vary. So the teacher or we are going to tell you the valence electron. Here you have 3A. So the valence electron would be 3. Here you have 4. So it's going to be 4, 5, 6, 7, and 8 valence electrons. The periodic table is divided into groups. Group A and Group B. In the first column, first you start with 1A, then 2A. All this is a group B. So first we start with 3B, 4B, 5B, 6B, 7B, 8B. You can only get to 8B, okay? So then you repeat again, 8B, 8B, 1B, 2B. And that's why you started here with 3B, because here you ended up with 2B. And then here is again the group A. But you start with 3A, because here you ended up with 2A. So it's 3A, 4A, 5A, 6A, 7A, and 8A.
Yeah.
Depending on the valence electrons that your atom has, it will get the ionic charge. If it's from 1 to 3, it stays the same number, positive. And it's called cation. So, let's say that you have an atom that is hydrogen. You will write hydrogen, the symbol, plus 1 because it's the ionic charge. And over here you will write cation. That's your answer. If you have 4, this will be your ionic charge. Plus, minus 4. And instead of writing cation, you will write cation slash anion. Not just one, not just another one. Both of them. And here, they are negatives. They are called anions. Just imagine that the 5, they all have to get to 8. Okay? So 5 needs 3 to get to 8. 6 needs 2, 7 needs 1. So, like, just imagine your answer. That would be, I don't know, any atom. I don't know. This one, you will put -3 and you will write anion. Okay. And then here, if it's 8, okay, all the elements that have from 5 to 7 valence electrons, they need to be neutron. So, the 5 needs 3 of ionic charge so it can be 8.
Compounds. Compounds are 2 elements or more that are mixed, so it's called chemically bonded, and it can take or share electrons.
One example of a compound is water, H2O. To make water, you have to bond or mix 2 hydrogens, that is here, H2, and 1 oxygen. So you bond them and it forms water.
And it forms an element.
Okay, as you already know, if you have this amount of valence electrons, you will have this, that is your ionic charge. This is the base, so you can do it on a compound easily. I'm going to do an example. Here's cadmium with here they are already giving you the amount of its ionic charge. But you need to know the ionic charge of oxygen. So here we come, and as you already know, here is oxygen. So it's 3A, 4A, 5A, 6A. If you have 6 valence electrons, you would have -2 ionic charge. So it's oxygen -2 cadmium plus sulfur. Now we're going to do a switch. This ionic charge and this would change, but the positive or negative don't change. So it's gonna be cadmium, and always here you have them at the top, so you're going to change them and cross them at the bottom. It's gonna be cadmium 2, because here you changed it, and oxygen 3. But you also need to put the name for it. So it's gonna be, and always this first positive, okay? So, okay, so it's gonna be this, okay? So you're gonna put cadmium 3. It's before you change the name, but here you have it. So it's gonna be cadmium 3 and oxide. As you already know here, anions, that are the negative ones, always end in IDE. The negatives are going to be after the positive. The positive is always first. So if I give you oxygen with cadmium, you would switch them again because it's always the positive. Here we're going to do another example. Strontium with nitrogen. Let's find strontium. Strontium is here. 1A, 2A. So it's gonna be either 2 valence electrons, you will have +2 in ionic charge. It's gonna be strontium +2. And nitrogen, here you have 3A, 4A, 5A. If you have 5 valence electrons, you will have -3 in ionic charge. It's gonna be nitrogen -3. You're going to put strontium +2, nitrogen -3. Here you cross them. So it's gonna be strontium 3, nitrogen 2. And the name would be strontium parenthesis Roman number 2, because you put it before you changed it, nitride. And all this is gonna be your answer, as equal.
Okay, so here you have iron with 3 on top and antimony with the 2 on top. Now you have to exchange them and rewrite it with iron with 2 on the bottom and antimony with 3 on the bottom. But you just use the positive charge, so you cross out the number 3. Because iron is the positive. Now you write the expression with words. Iron parentheses 2 antimonide. You have to end the word with ide. Antimonide. Iron 2 antimonide. Here you have manganese, fluorine 3. So you exchange the numbers, and now you have Mn3F, manganese 3, fluorine. But remember that you always have to end the second word with IDE. So it's manganese 3, fluoride with IDE in the end. Now we have calcium 2, oxygen -2. So you exchange the numbers. And now you have calcium 2, oxygen 2. So, because 2 over 2 can be simplified, you put them as 1. And the 1 doesn't count, so you can put calcium oxide. Here you have sodium, Na sodium and Cl chlorine. Sodium has 1 valence electron. Chlorine has -1 valence electron. So when you exchange them, you have sodium 1 and chlorine 1, but the 1 doesn't count, so you can write sodium chloride always with ITE.